Hello and welcome to Don't Worry, Be Appy, addressing AppSec's newest challenge. If you're joining us live, our speaker is in the Slido discussion answering your questions right now. For audio or video issues, please click the technical support button below. I'd now like to turn it over to Erez Yalan for the presentation.
Thank you very much, Ali. Really happy to be here, and thank you all for joining me during these trying times. It's great to be again in RSA conference. Okay, so let's start with a question. The question is, what do all these companies have in common? So I'm pretty sure some of you have several answers to that. I'll give you another second. If you answered, all of them had some sort of API security issues, that was the right answer. And if your answer was they had API security issues recently in the last few months, then your answer was even correct. So what is it about API security that makes everyone so vulnerable? Let's see. Let's start with defining what API security is. This is how we start things. So we go for Wikipedia, we see that an API is an application programming interface. It's an interface or communication protocol between a client and a server. So far, so good. These days, we use the client and server terms in a broader way. So basically, we mean that the API is the interface or communication protocol between every component in our system. So each component wanting to talk to another component will be using an API. So who uses APIs and what uses them, which technologies? The quick answer is everyone, everybody. We can see that every modern application these days uses APIs, definitely microservices and mobile and IoT. B2B, serverless, everything that is cloud, and today we see a lot of single-page applications. These are all using APIs. So we love APIs, we use them, and they are the beating heart of modern application. What is the difference between traditional and modern application? Why am I saying that we need to put a bit more emphasis on their security, and what is the knowledge gap we have today? So let's start by comparing traditional applications to modern applications. So let's start with what is similar. The similarities are users that are interacting with some sort of client. When in traditional applications, we used to have one specific client. It was usually a web browser. Obviously, these days with modern application, it doesn't have to be a web browser anymore. It can be a smartwatch, a scooter, it can be a mobile phone, it can be another B2B component, smart toaster, you name it. So the second part that is similar is the connection between the server and the database. The server will request some data from the database, and we'll expect to get the data back. Now, the difference here lies in the database itself, which in traditional application, it used to be more of SQL, and now we see more NoSQL, Elastic, etc. And also the server that used to be a traditional server as we know it today does not really have to be an actual server. It can be a cluster of microservices or any other thing that functions as a server, as the backend. So here comes the difference. When our client needs to show a page, for example, to a user in a traditional application, there is a GET request that's being sent to the server. The server will turn on the logic, will gather all the information, render a full HTML page, and return it to the browser. As we said, these days, the browser is not a single client possible. There are many, many possibilities for clients with more and more joining us every day. So it's a bit different. Now we have the client just asking the server for specific bits of data. We get a series of API GET requests the server will aggregate all the information and send back just the raw data, sometimes raw parameters, and we expect the client to arrange them and filter them and put them the way they're supposed to be and to show what they're supposed to show. This is a very significant difference because it means that the logic phase is on the client side. Another difference is abstraction layers. We can see that there are less abstraction layers, and the client and server and database actually speak the same JSON language. We see that every part can be used by sending and receiving JSON, which makes it very flat, let's say. So what makes APIs vulnerable? There are three different reasons that we can look at. The first one is the abundance of API endpoints that make the attack surface much bigger. So if in the past, in a traditional application, in order to get to a database, I had to go through module A that was in charge of authentication and authorization, for example, and only then go through B and C. Maybe these days I can try and hack myself in through module H that also connects or exposed to the API of module B. So we can see that the endpoints are out there, sometimes in the open, and they make the attack surface bigger. The second reason is that clients consume raw data, and we saw that. More parameters are sent in each HTTP request. Sometimes it's object IDs and values and filters and whatnot. We just see raw data flying through the air. When component 1 here sends information to component 2, then component 1 may be sure that component 2 is inside the network or inside the organization and is protected. So maybe they would send some sensitive data. But component 1 does not know that component 2 will use this, for example, sensitive object to be sent outside to component 3. And it's very, very easy to lose the destination of sensitive data when you have complicated networks of APIs, microservices, etc. The third reason is DevOps or DevSecOps these days. DevSecOps became so flexible, so efficient, almost too fast to handle. We see that the flexibility of CI/CD processes are getting more and more efficient and quicker. It's almost effortless to deploy a new microservice, a new container, a cloud infrastructure, full sets and versions of APIs. And it's very, very easy to deploy and forget, and to keep these APIs just floating there without no one remembering what they did and that they are actually there. So I guess by now you're thinking, oh no, what did we do with APIs? So it's not all bad. It's not all bad news. We know that traditional vulnerabilities are less common these days in API-based apps. We see that injections like SQL injections are less and less common. This is thanks to increasing use of frameworks and ORMs, etc. We see that cross-site request forgeries are less common also. This is thanks to authorization headers used instead of cookies. Other things that we see less common are path manipulations, for example, because more and more storage is cloud-based these days. Now, I'm not saying that path manipulation is not a thing on the cloud. It is a thing, but it is definitely less common and also usually less severe because it's contained. And in general, a lot of classic IT security issues are being solved slowly but surely with different SaaS approaches. So, as I said, it's not all bad news. How do you bridge this gap? So, I work in Checkmarx and we see every day a lot of mistakes that are being introduced into code. And together with the migration of the technology towards APIs and microservices, we also saw the mistakes, obviously the security mistakes, migrating to there as well. So in order to see how we bridge the gap, both for us and for the entire community, we decided to go and do some research. Usually when we're trying to learn something new, we go to OWASP. I hope everyone that is listening at the moment and watching this know what OWASP is. If not, go and check them out. So OWASP is the Open Web Application Security Project, and the most famous or most useful asset so far is the OWASP Top 10 that was released in 2017. But we saw there a lot of solutions to traditional applications, but not to API-based applications. So we actually were left with the same gap of knowledge, and we had to fill it out. So we decided to fill it out by ourselves. With great help from my friend Inon Shkedi, we founded the OWASP API Security Project, started defining the different issues and problems we see these days with API-based applications. And we managed to define, after about a year of work, the OWASP API Security Top 10. Now, unfortunately, we don't have enough time here to cover each and every category in the OWASP API Security Top 10. This is something you can find online and improve your knowledge. But I do want to point several points here. So in this list, we have four different groups. So the first group is the group we, let's say, stole from the OWASP Top 10, the original one. We feel that injection issues, as I said, they are decreasing, but we're not done with that yet. So it's not the #1 issue. It's API 8 now in our top 10, but it's still a thing. And API 10 is insufficient logging and monitoring, not directly, we're not directly looking at that as a security issue, but we should, because if a specific application is not doing the logging as it's supposed to, or doing the monitoring, then it can become a security issue. The second group, which we will talk more in detail later, because this is the biggest challenge of API security, is the access control group. Everything that is about authentication or authorization, we can see that we have 3 different categories that are about access control that are part of the top 5, let's say, from the top 10. So we have broken object level authorization and broken authentication and broken function level authorization. Obviously very, very important, and we will discuss that deeper later. But in general, it means that I need to know who my user is, what they can do, and what kind of objects or assets they may touch. And if I don't do that, we see things like that. For example, a couple of months ago, we published that a research we did showed that one of the smart vacuum manufacturers created a vacuum with a camera on it. Not sure why, but I guess they believe it's a good idea, and also their customers. The problem is that access control was not employed as it was supposed to, and during some API researching or hacking or pen testing, we managed to get access to the video feed of each and every user around the world. So this is a result of problem in access control. In this case, we managed to get the video feed and location and the form of the room inside and more sensitive data. So this is the biggest challenge, and as I said, we'll talk about it in a second. Let's continue with our third group. The third group is the access data. Remember I mentioned some minutes ago all these raw parameters flying in the air. So they got two different categories here, both API 3, which is excessive data exposure. It means that sometimes I would use sensitive parameters or sensitive data for being sent to another component without actually being able to follow where it gets. And sometimes it will get to a client that I don't want to get. I don't want this client to get it. One of the biggest mistakes is thinking that if I filter it in the client, then the user will not see it. Obviously, this is a mistake because an attacker or a malicious user will look at the JSON files, at the traffic that comes to the client, and not specifically to what the client chooses to show us. The other side of it is mass assignment. This is where you get a lot of information from many sources. Some of them may be untrusted from users or malicious users, and you, because of the confusion from where this came from, you believe that this is trusted data and you use it in a trusted manner. Obviously, this is also a problem. So an example for excessive data exposure of data that being filtered on the client, we saw about a year ago. This is a good example that I enjoy to show every now and then. An application called 3Fun, meant for hooking, I guess, hooking up. They sent a lot of information. Obviously, when the user looked at the profile on the application, they got only to see the non-sensitive information. But when looking at the traffic that comes from the server to the client, you could see a lot of sensitive data, including location, specific location, like GPS specific. The interesting thing that made it famous is that the researcher, Alex Lomas, decided to map these points around the White House, which obviously made a lot of noise, but this is a classic example of the issues of excessive, of exposing excessive data. Moving on to the fourth group, this we kind of bundled under DevOps or DevSecOps, and these are the everyday things we do to protect our functioning code. So, for example, API 4 is about the lack of resource and rate limiting. All of us know that if we do not protect and do not put some sort of rate limiting protection or protect our resources, we are subject to denial of service. This denial of service can be from the network or from an application or whatever other source. But another issue that can come from forgetting rate limiting is the ability to do some brute force and to try and hack through guessing and enumerating usernames and passwords. API 7 is called security misconfiguration. It's a big bucket of well, all the security misconfigurations you can think about. There are a lot of those. It can be anything from, as we said, rate limiting to using HTTP instead of HTTPS, etc. There are many security misconfigurations that can go wrong. And the last one, last but definitely not least, is API 9, improper assets management. As we said, it's very easy to deploy these days new APIs and completely new versions of APIs. Just in a click of a button, it takes between minutes and sometimes even seconds these days, and it's very easy to forget them. So without proper assets management, yes, I mean documentation sometimes, and clear policies and clear processes of how to deploy new APIs and how to deprecate all the APIs, you are left with sometimes a big mess of not knowing what kinds of APIs and assets you actually have. So let's see an example of a security misconfiguration. Also, just a couple of months ago, the big Google. Google Firebase allowed some unauthorized parties to easily found the databases of many 24,000 Android apps just because of data exposed through a common misconfiguration. So it's really easy, and it happens really to everyone just because it's easy to toggle something off. As I said, the biggest issue or the biggest challenge is access control. So I would like to attend to that before we move on. So access control is API security biggest challenge. Let's look again at the three categories that are part of it. So we have API 1, broken object level authorization. We call it BOLA. This is basically about what an authorized user can or cannot touch or access. Broken authentication is to make sure that the user is authenticated correctly and no other user can claim their identity. And broken function level authorization is similar to API 1, but instead of what a user can touch or access, API 5 is broken function level authorization. It's what a user can or allowed to do, the actions. And let's take a look in that. So let's start with API 2, the broken authentication. When we look at that, we are talking about two different and completing issues. So the first one is lack of protection. For example, if you have an API set of, we have here 5 different APIs, API endpoints. We see login and another kind of login, and forgot password something, and update location and edit photo. So what we expect this API to cover or to be protected is against rate limiting, to have a rate limiting protection like we discussed before. But this is not all. We see here 3 APIs, 3 endpoints that are touching login or about login. So I would expect some extra protection for that. And this extra protection can be either an account lockout mechanism or a CAPTCHA or credential stuffing protection or anything that is specifically aligned in protecting login-related endpoints. The other side of broken authentication is sometimes misimplementation. And this can be from many different reasons. For example, when you have a JWT and you're using that, that's an excellent start. But if your encryption algorithm is none, then you obviously did not do something well. Again, sometimes the service does not validate the OAuth provider. We see passwords that are stored without salts, and many other reasons for these misimplementations. All of them result in broken authentication. Why are these errors so common? So we said that authentication endpoints are just out there. Some of them are exposed to anyone by design. The software security engineers have sometimes misconceptions. Obviously, not everyone, but we see it. We see it a lot. We need to remember that OAuth isn't authentication; it's authorization. We need to remember that API keys should not be used for user authentication, but for client authentication. And multiple authentication flows exist in modern application. We see it especially in IoT and mobile, but also obviously in legacy and deep links with credentials. And you have a lot of different flows to authenticate a user these days. And they all run in parallel. So it's very easy to make a mistake. Let's move to API 1, BOLA, broken object level authorization. The situation to be described is very easy. If a user asks for their own document, they should get a response, of course, and get the document. If a user asks for another document, then they should not get that. And if they do get some sort of access to someone else's document, then we have broken object level authorization. I think the concept is very, very clear. Why are errors so common? We saw that before in the beginning. So the attack surface is much wider and it's easy to try and bypass the areas of authorization. And unfortunately, there's no security solution that solves the problem completely. This needs to be baked into the solutions from day one, and the entire architecture needs to be involved in that. Some of you say, oh, so that is IDOR, I hear you cry. It's not IDOR, we don't call it IDOR, and the reason is that we believe it's not accurate or indicative enough. When saying IDOR, we talk about insecure direct object reference, and we don't feel that the direct object is the problem here. We think that there shouldn't be something, we don't think that everything should be salted or hashed or added a random string. So we think that just the authorization should be fixed. Obviously, try to ask your developers to implement indirect mechanism in every place that receives an ID. I think you'll get a strike. And the last thing is that the problem is not the object reference, it's the lack of authorization in our eyes. So we decided not to use IDOR, but the new term BOLA. And the last part in this access control is broken function level authorization. Again, easy to define. If an admin asks for an admin API, they should be okay with it. And if a regular user asks for it, they should be avoided from accessing it. Why is it so common, this problem in APIs? So the function level authorization can be implemented in many different ways. It can be in the code, in configuration, in API gateways, and other places. Also, it's really easy to detect and exploit APIs because the endpoints are predictable. Let's see an example of a traditional app. If you want to get a user's profile from a regular endpoint, it looks like you see here on the left. And if you suddenly want to delete a user as an admin, then you need to go to the admin panel and try to get into the user management, use some sort of post, and to be able to do that. Now, how it looks like these days, you just switch the get into delete, and as you can see, it's very, very predictable. Let's summarize. So, what you need to remember, hopefully, after this talk. So modern API-based applications are different. We saw how and we understood why. Being different, they have their own security issues. I hope I convinced you in that. The attack surface is much wider. There is more data moving between components, sometimes raw. And access control is a real challenge. What you need to do. So first of all, educate. There is no defense against threats you don't know. The way we trying to close the gap now is part of it. Educate yourselves, educate your developers. Again, what you don't know, you cannot defend from. Keep an up-to-date API inventory. You cannot protect what you don't know you have. And last but not least, embed access control best practices from the beginning, from the start. And it goes, a good way to use that and to do that is by talking to a developer and telling them to implement instead, for example, a user gets access to their document. You can ask a developer to do a task that only that user gets only read access to their document. This can sometimes help the developers with the requirements for access control. And that's it. Thank you very much. Thank you so much for joining me today, and have a great day.